Hello everyone, this is Bradley. Today I'm going to make a tutorial with this moving holes animation. I want to firstly remind you that this animation is inspired by Alexander using Cinema 4D with or without X particles. And I have done a tutorial in the past. I have two types. One type is trying to purely replicate what Alexander did, in which all holes are almost rigid and have ability to repel each other. The other is where the holes are allowed to merge together. The type 1 was almost a failure at the time because there was a limitation in animation nodes, and thus I made a type 2 that was successful and new to the entire series. Almost the tutorial is not 100% outdated, so I still recommend you to take a look at some point. Maybe some of the techniques may be useful in other cases. And earlier, there was a new node coming out for animation node, which is called close packing node. It has a very similar function to Cinema 4D's push-apart effector. So now it's nearly possible to accomplish the type 1 animation, along with the type 3 animation in which all materials are scaling up and down in the animation. The close packing nodes can be used with an old method. The close packing node can be used with the old method, but today I'm going to show you another method to work with this whole thing. This method essentially comes from Alexander, and it's his way to do the animation without X particle system. Anyway, this new method may be better or worse compared to the old one, but anyway, let's start. So let's firstly do some very basic modeling. Let's hit a circles, and let's fill the circles. Let's hit I to insert that, delete the interfaces. Be aware that this part is not really procedural. And I'm going to extrude upwards with a certain thickness, and I'm going to hit Ctrl R for the loop cut. Then I'm going to select the out of one of the ring, extrude along normals. So now we have a very basic mesh which is available for our instancing to generate more kind of interesting structure on the sphere. Next thing that we need to do is to generate a sphere for instancing our holes. And you may think, let's just add a eevee sphere. However, we're going to use another method, which is use a plane. And I'll explain how to do this. Let's firstly rotate this for 90 degrees. And I'm probably going to scale that up for maybe 5 times, or I don't know, as much as you wish or whatever. And then I'm going to subdivide that with a modifier and change the type to simple. So this is basically the same as you just hit the tab, goes to edit mode, and right click for subdivision. The only difference is this is completely procedural, so you don't need to worry anything further. Just to make sure your render setting always match the viewport setting, because this is so important. Next thing is to just use the simple deform. And I'm going to set the type to bend, and you can see even if I change the values, it does not actually work in the way I want. The reason is because this modifier is so weird that I don't understand it very well. But the only thing that you need to do is essentially just Control A and apply the rotation. So now it actually works. This is really a very weird modifier, I have to say. And if I bend that to 180 degrees, you can see now it forms half of the circles. And if I copy this modifier and change the other axis for bending, and now it forms half of the circles. However, I cannot. It forms another circles, and finally it turns to be a sphere, a very cool sphere. However, the issue is that it cannot turn into a full sphere, is because if you try to increase this number, or you increase the other numbers, you can finally see that there is a severe overlapping of the edges by the end. And if you form the 360 degree, in general, it just won't work in the way you want. And I never understand why exactly this is, but this is almost how it actually works. So, but it's okay to keep only half of the circles. I think it does not really matter. So let's keep the simple deform away, because actually these are not needed at this stage. Next thing I would like to do is to generate holes on these planes. And here's the moment where things get diverged, because as what's happened in the last tutorial, there are two ways to generate holes. One is to use the Boolean. The other is to use the for. A disadvantage of using the Boolean modifier is sometimes it generates errors, especially if you're animating all these hole movements. The geometry will flash due to n-gons or whatever other stuff which occurs in the Boolean. But if you're using for method, it will be super accurate. So in this particular case, I think I'm going to adhere to the for method, which I think is super great. So let's take the for method. Firstly, let's take a distributed matrices, and let's take a 3D viewer to take a look about what we are generating. To make the yes, and I'm going to hit the select the node, hit W, and it goes to X division. I'm going to synchronize the count on X and Z, and be aware to take ticked on this offset, so it's centered on axis. And then I'm going to do the same thing with the width and height. I'm going to keep using the size so that even if I'm increasing the counts, the entire grid is still limited within the plane. And you can scaling that up and down to change the limitation. Next thing I'm going to do is to use the vector mask and the vector wiggle. And let's generate a list. Put the list into B. Put the vectors into the count, then it will automatically get a list length. So I'm generating as many random vectors as the vectors generated from the distributed matrices. And then let's take a look with the vector mask. So now all the vectors flies away. I don't want it flies away from the plane. Actually, it's doable, but I don't like it. So I'm going to cancel this Y to place. But I also would like to synchronize the XZ value. So there are many different methods. So you basically can just take a amplitude and float input on X and Z. Take a 5, something like that. Then you get a kind of idea. And just make sure it's not too much, or you can decrease the limitation. I don't know what to do. But definitely, if now you're trying to instance objects onto each of the points, then you can actually already see the overlapping. And here's where it comes with our close packing node. You just put the results into the points, and it will generate the matrices. The reason it has to output the matrices is because there are several modes in this entire node. I think I'm going to make individual tutorial talking about this close packing node, but just to basically mention several important concepts with this node at this moment. So if you're using the dynamic radius, so there are 3 ways to avoid intersection. One is you hide overlapped objects. The second is to scale up and down the object. The third is to use like a rigid body or physics to repel the object, something like that. So this is kind of 3 ways of thinking. Dynamic radius, as it has been stated, it will change the scale of the object to avoid the overlapping. And what you can actually see is the radius here is actually you can already see how matrices actually has been modified in this case. Like some of the matrices will be finally scaled to 0 due to the overlapping with the others. So in this case, it will actually automatically generate kind of random scales. And by the way, this is why it has to output a matrices while input a vector, because matrices is a data which includes all these not only location but also rotation and scales, so on and so forth. So if you use dynamic radius, you no longer need to actually concern about the random scale. It's actually kind of very convenient. And let's just take a time info node and put that in evolution, so that if you're trying to play in with this animation, you can see how things actually goes around on this plane, which is kind of actually cool. However, if you try to use the fixed radius, I think what it does is actually to hide the other object. Personally speaking, I don't think this is what I want, because it will generate a flash. If it's static, I don't care, but if it's animating, then this flash definitely is bad to me. And there's also other option you can try to test by yourself, but these are basically concepts. Using the relaxation, however, is important. It basically will push everything apart like a rigid body. So now you can see it turns to be very jaggy, and it's not beautiful. It's not beautiful at all in this case. However, if you decrease the count, if it's not too close packed, then sometimes it will kind of generate kind of interesting result, which is not too bad. And it's still very accurate. So these are the things that you need to consider if you're trying to making this kind of animation. But I'm not going to further details into this. So you can do either of them. Who cares what you actually do? But I'm going to go further. Margin is basically just a protective border, like how closer you allow them to be, something like that. So on and so forth. Like just and the step is more like kind of accuracy, but I think it's already accurate enough, so I don't really care. Fourth, I'm not going to take care of at this moment. So let's just go ahead. Next thing to do is to generate the fourth. And you may think, since we have matrix, so we can take object matrix outputs, object controller fourth, object instancer. So it's possible that you put a object instancer, an instance of controllers, and matrices into matrices, object into objects, and object into object controller. And now we have a fourth, which is nice. However, this actually is not the way to do. I'll explain why. The reason is because you generate a matrices using the nodes, and the matrices is drive the object, and you're using the location of the object to drive the fourth. So there, the shortcut is more likely you use the location of the matrices to directly drive the fourth, instead of using the matrices to drive the object and then to drive the fourth. It does not make sense in this case, right? So what essentially the disadvantage of really doing this is it will generate lag within the fourth compared to directly use the matrices, and this lag will be almost kind of fatal. So you can try this by yourself, but I'm not recommending this method. So no, I'm not going to do anything with object instancer in this case. Rather, I'm going to actually decompose the matrix. And then I'm going to plug everything into point distance fourth. Point distance fourth is basically a spherical fourth. It's almost the same as the object instancer. The only issue is you don't see the object instancer. Another issue is that within this point distance fourth, it does not receive multiple inputs, which means we have to use the loop. So let's hit this node and hit W, and goes to right, we have a translation. So what basically a loop, what a loop does is if you input a list, and for each element within the list, it will form a single loop. So now it can be plugged into the point distance fourth. And I'm going to generate another vector list. Put the scales into that because scale is also a vector. And I'm going to plug that into the sides. And I'm going to probably turn the fourth width to 0. There's a tutorial talking about how to visualize the fourth and so on. I'm not going to detail about every of the parameter in this case, but you can try by yourself and see which works best for you. So now I go back to a fourth list. What's next? Next is to let's try to object mesh data. Here I'm going to select this plane and use the modifier so that I read it into the subdivision surface. And then I'm going to offset vertices and I put the fourth list into the fourth. And it actually does not work again because this fourth has to receive a single fourth instead of multiple. So does it mean I need to still run a loop? No. It actually means you need to mix the fourth. And then let's hit this list icon. So in this case, we're merging all the fourth into a single fourth that can be plugged into. So now we have the offsets, vertices, and then we need to output this new mesh. So now let's add a target plane. And nothing happens because I canceled all the offsets. But if you try to increase these offsets, you see the effect. And let's hide the original plane. And this is it. Another good point of using the point distance instead of object controller in this particular case is it becomes super fast compared to the object controller. Because definitely if you're using object controller, you're looping around. So this is super awesome and very nice. So here we generate all these holes, and you can even try to interpolate this valve in the way you want, like maybe make it very sharp, or I don't know what can you actually do with that, but feel free to play around with all these settings. And the holes are just the holes. You can even change the valve width, but I don't recommend to change it too much because other issues that may exist. But if you use the valve width, then definitely it will make it makes less jaggy. So this is many different ways you can think. Anyway, I think I'm going to move on. The next thing I'm going to do is to instance our object. Let's name that as instance the object. So now we have an instance the object. Let's rotate that 90 degrees. And I'm going to use another way of instancing, which is kind of nice for many objects. So let's duplicate these object mesh inputs. Let's select our instance object, and I'm going to use the transform mesh. This node is very tricky because it does not only transform the mesh, it also replicate the mesh if you want. So now if I put the matrices into place, into the transformation, then you can see it actually allows you it allows a multiple input of transformation, and what it finally does in such a cases is it will let's hit another target. It will actually replicate the mesh. So this is what actually finally happens. We instance the object, and this is cool. The next thing, I think let's disable this 3D viewer. So this is good enough, and you can scale down the radius, and so this is basically it. You can also try to remodel these entire things to change us to cover up all these kind of defect jagginess, or maybe you can deal with some size valve width. I don't know what you can actually do with this, but feel free to play around with all these settings and the modeling. So this is one important part, and definitely it's animatable. It's smoothly animatable, like scaling around, and very fast. Very cool result. And you can use the relaxation so that they don't actually collide each other and so on. You can also increase the margin, like 0.1, so that it goes more accurate and so on and so forth. So whatever, feel free to play with all these settings by yourself. The next thing is I'm going to fold everything into a sphere. But and here's the one thing that you need to be aware. If I'm folding these two objects individually, it will actually generate error. The reason is that if I go to the items, I go to the N panel and look at items. So now I have an instance collection, and you can see its dimension is like 8 meters, 7.5 meters, and so on. But for our plane, it's like 10. What I would like to say is because their dimension is different, which also means while they are trying to be deformed with this simple deform, their their radius of the sphere will be different, and it will generate error like this instance collection won't actually be matched into all these holes that has been generated. So this is an error. To avoid this error, it's very easy. You just merge these two objects together. And to do that procedurally, I'm going to use the node, obviously. So let's create mesh list. Put the mesh 1 into one location, put the mesh B into other locations. And let's put this the mesh list into the mesh. It will automatically join the mesh list. And let's delete the instance collection. So you no longer need that, and it won't ever move. It's a dead mesh already. So let's just delete that. So now we have a target plane, which is a single object. The side effect is definitely you can only wait. Yes, the side effect is that a material will be applied to everything, but I don't think it's a major issue that you need to consider. And this is it. And it's still animatable. Reading everything is very, very well. So this is very good. So final thing is what you need to do is to just use a simple deform, bend 180 degree, and copy. Change the axis with still 180 degree. Then you get kind of nice result. And it's possible that you try to shade it smooth. Who knows what you would like to do. But these are the things that you can potentially play around with, including the modeling and whatever other stuff. So feel free to play with that, including increase the margins. Like I would like to keep the margin high. Something like that. And you see, if I change the meshes, the shade smooth will also be also disappeared. But you can add a shade object smooth. Just yes, shade object smooth. You can shade the object smooth with the nodes, and then so on and so forth. There are lots of things that you can potentially do. Who knows what you actually would like to do. And for the inner sphere, it's just take the UV sphere for the inner. Scale that up. And by calculating the radius, actually, because you know this plane is has a dimension of 1010 originally without the deformation. So what it means is its radius is about 5. So the 5 is basically the center point. I suppose. But maybe I'm wrong. Who knows? But you can try to eyeball that to get a center. Something like that. Just play around with yourself. That's what I can actually say. Because I don't even actually know the correct answer. So, but basically this is it. Although it's a kind of half sphere, but you can potentially mirror this with a mirror object. Like you take the mirror object. Let's take a mirror. Like use the mirror objects. Let's use our spheres and let's mirror on Y. Then you get a whatever stuff. So this is one way of doing that to form a full sphere if you wish. Or maybe you have other ways to actually transform a plane into a sphere. I don't know. Or you can just really use the 360 degree, but sometimes it may potentially generate errors. I don't know. Either way, who knows? Play around with all these settings. Just another thing, be aware if you are not satisfied with subdivisions. I recommend you to change the subdivision from the initial subdivision, or from the initial sample plane. Also, I think if you try to render this object, you can see the plane has not been disabled from render. But if you try to disable from the render, sometimes the object mesh data node cannot read into modifier. This is not a bug. It's because it's setting off the blend itself, and it makes sense that you don't want to access an object that you would never see from the renders with its modifier. So there's to solve that problem, that if you don't want to see this plane, you either hide this from the viewport and render from viewport animation, or you just take off this word space and move this plane away. And by using this method, again, it causes another problem, is because we're not using the word space, so that all the rotation is not applied to the meshes. And in this case, what I would do is just offset matrices with the transform, and let's kind of try to rotate that 90 degrees with a node, and it will fix all the problems. Things like that, and you can apply the materials, share the materials, and so on. I think this is basically it. So I think this is it. And I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.